Okay, welcome to Algebra 2, Semester 2, Unit 11, Section 6.2. What we're going to do today is apply the properties of rational exponents. You're going to recognize it from the properties of exponents from Algebra 1. We're just using it with rational exponents now. So remember when we used to have the same base multiplied, we would just add their exponents. So this would become am plus n. Well, now, when we've got the rational exponents, it's the same thing. We just add them together. Make sure that you write the base and then show the exponents being added, 1/2 plus 3/2. They've got like denominators, so we know that that would equal 5 to the 4/2. Well, 4/2 can reduce. 2 will go into both 4 and 2, or 2 will go into 4 2 times. So that would be 5 squared. And that's how you would end it. Now, since it's such a small number and you can easily figure it out, on a regular problem, you'd go ahead and say that that's 25. I want to just show you in these rules what happens with the exponents. So that's why I'm focusing on that. Okay, the next one. In Algebra 1:1, when we learned the properties of exponents, we knew that if we raised an exponent to a power, we simply took that exponent and we multiplied it. Okay? So here we have 5 to the 5/2 raised to the second power. We're going to take 5, you need to show this, write the base 5 to the 5/2 times 2 over 1. That would equal, whoops, we shouldn't put an equals up there, we should write the whole thing with the base again. That would equal 5 to the 10 over 2, or you might have reduced by reducing those 2's. 10 over 2 is equal to the 5th, so that would be 5 to the 5th. With the calculator, you could give me a final answer, but again, I'm wanting to focus on this property and how we multiply the exponents when we're raised to a power. Okay, in this one, you need to realize A has to the first power, B has the first power, so we're just multiplying that m by each of those, so it would be A to the 1 times m, B to the 1 times m. Now the same thing when we put actual numbers in here. We have 16 to the first power, 9 to the first power, so we multiply the 1/2 by the 1, and we end up with 16 to the 1 times 1/2, 9 to the 1 times 1/2, which equals 16 to the 1/2 times 9 to the 1/2. Well, the 1/2 root of 16, that's just simply saying the square root. It's saying the square root of 16 times square root of 9 is what that's saying. Remember, a square root has a 2 out there that we don't have to write because it's our most common root. That's how we get that, the ones on the inside. So the square root of 16 is 4. Square root of 9 is 3. And we get 12 as our final answer. Again, I'm wanting you to show all the exponents here, what's happening with them. A to the negative n, we write that in simplified form as 1 over A to the m. So here we would write this as 1 over 36 to the 1/2. Now, 36 to the 1/2, just like up above, those problems just a minute ago, that's the same thing as 1 over square root of 36, which is 1/6. Make sure you've memorized your roots and your cubes. It will help a lot in this chapter. A to the m over A to the n is equal to A to the m minus n. Okay, so if we end up with 4 to the 5 halves over 4 to the 1 half, we can simply subtract their exponents because they're the same base. They have to be the same base. So we have 4 to the 5 halves minus 1 half, which would equal 4 to the 4 halves. 4 halves reduces to 4 squared. So that's equal to 16. Okay, again, show all the exponential rules going on there. A over b to the m. Well, each of these have a 1 by them, so it's just like up above when we had the 1 by them when they were being multiplied. This is the power property of a product. This is power property of a quotient. Same thing though, it'll end up being a to the m, and then instead of times b to the m, it's divided by b to the m, because that's how the original was set up. So here we would have 27 to the 1/3 divided by 64 to the 1/3. That is the cube root of 27 divided by cube root of 64. Now, if you have not memorized your cube roots and square roots, then you would have to work that out. But since I've memorized them, I know a cube root of 27 is 3, cube root of 64 is 4. So that would be my final answer. Make sure you're showing all the rules. So when we get to this one, in order to write it, you have to show the rules. So show, since it's the same base, we just write the base once. And when we multiply, we add the exponents, 1/4 plus 1/2. So that means it's 7 to the 3/4. Circle that final answer. Now this one, we're going to take the 2 and we're going to multiply it by each of those fractions, and that is 2 over 1. So it would become 6 to the 2 over 2 times 4 to the 2 over 3. Okay. 6 to the 2 over 2 is the same as 6 to the first, so we'll just write 6 times 4 to the 2/3. You can't multiply those before you raise that to the exponent, and I wanted an exact answer, so I don't want you to raise it to that exponent because that would cause you to have to use a calculator and you would end up rounding. Okay, I believe that is page 3. Now we're going on to page 4. Page 4 of this unit. Up at the top, we just have properties to practice here. I would prefer that on this page you do a few and then you pause the video and do a few and then you come back and watch them and see if I've done them the same. On those that you're not sure of, don't do them and wait for me to do them with you. I'll explain all of my procedures, but go ahead and pause the video and do about 3 of these and then turn it back on. So on this one, I would draw my arrow that I am going to distribute, but first, since it's a negative, I'm going to put it underneath 1. Flip it to the other side. So now I have 4 to the 5th times 3 to the 5th raised to the 1/5. And now I would end up simplifying that by distributing it. So 1/5 times 5 would be 5/5, or 4 to the 1st. I'll write 5/5 so I don't lose anybody. Okay, and 3 to the 5th times 1/5 would be 3 to the 5/5. Now that is 1 over 4. 5/5 is equal to 1. I don't have to put a 1 there. Times 3 to the 1st, which equals 1 over 12. Okay. Next one. Seems a little bit tricky because that 5 doesn't have an exponent, but it does have an exponent. We just don't have to write a 1. Now realize 1 is the same thing as 5 to the 3 over 3, so I'll just write 3 over 3 minus 1/3, because we can subtract our exponents when we're dividing. So that ends up equaling 5 to the 2/3. I want exact answers, so please don't use calculators on those to show me the simplified answer. Next one. We would multiply this 2 into each of these, so we end up with 42 to the 2/3 over 6 to the 2/3. Now, we can take it one step further. This would be cube root of 42 over 6 squared. Well, we know that 42 over 6 is equal to 7, so we can at least make that equal to 7. It would be 7 squared inside of the cube root, and since we want the answers written in rational exponent form, we could bring it back out to being 7 raised to the power of 2/3. Okay. Next one. We have 2 2/3 plus 1/2. Well, now we're taking fractions that don't have like denominators. So you need to make sure that you remember on fractions without like denominators, we have to get a like denominator. So we have 2/3 plus 1/2. Common denominator would be 6. 3 times 2 is 6. 2 times 2 is 4. 2 times 3 is 6. 1 times 3 is 3. So we end up with 7 6. And that's what our answer would be here, is 2 to the 7 6. Okay. Questions at all? Make sure and bring them to class. Write them in your notes so that we can answer them at warm-up time. Okay, next one. We have to distribute this 3 in here, so that would become 5 to the 3/3 times 7 to the 3/4. The only thing that we can simplify here is 3/3 is equal to 1, so it's 5 to the 1st times 7 to the 3/4. Okay. So here goes our next one. This is a negative, so please put it on the bottom right from the start. So it's 1 over 2 to the 6th times 4 to the 6th raised to the 1/6, which is equal to 1 over, now we distribute that in, 1/6 times 6 would be 1, so it's 2. 4 to the 6th times 1/6 would be 4 to the 1st, so it equals 1/8. Okay. Next problem, this is really 3 to the 1st, which is 4 over 4. So we have 3 to the 4 over 4 minus 1/4, which equals 3 to the 3/4. Okay, and the last one, we have square root of 20 over the square root of 5, or 20 to the 1/2, 5 to the 1/2. We could just write it as a square root, 20 over 5 cubed. Now you can take that 20 and break it down. It would be 2 times 2 times 5 over 5 That's how we can reduce those. So we end up with the square root of 4. Square root of 4 is 2. Raised to the cube would be 8. Or another way to look at that, you could simply do 20 to the 3 halves over 5 to the 3 halves. And just like we practiced a minute ago, that would be 20 over 5 raised to the 3rd and square root. So it would still come out as square root of 4, which is 2, raised to the 3rd, which is 8. 8 is your final answer. Okay? Add and subtract like roots. Okay? Here what we're looking at is we can factor out 8 to the 1/5 because they are like roots. So factor them out to the front, 8 to the 1/5 times 2 plus 10, because when you factor those out, that's what you have left is 2 plus 10. 8 to the 1/5 times 12. Okay? Next problem. Go ahead and we distribute this variable in. So it's a variable of 1/3. We distribute it in. That would be 27 to the 1/3. P to the 3 times 1/3. 3 times 1/3 is 3/3. H, 12 times 1/3 is 12/3. Now we reduce these. The 1/3 root of 27 is 3. In other words, cube root is 3. P to the 3 over 3 is equal to P to the 1st. And H to the 12 over 3 reduces to 4. There's your simplified answer. Okay? I would like you to pause the video again and work on some of these and then come back and check it out and see what you get compared to what I get. Okay? Next one, we would factor out the x, y to the 1/4. Or you could look at it as like terms even. And you have 3 minus 8 left over. 3 minus 8 is negative 5 x, y to the 1/4. Final answer. Okay. Next one, we have fraction here. We have 6 over 3 that we'll deal with in a minute. And then we have x to the 1st minus x to the 1/2. So 2 over 2 minus 1/2. And then y is 3/4 minus 1/2. Okay, so we have 6 over 3 is 2. X to the 2 over 2 minus 1 over 2 is x to the 1/2. And 3/4 minus 1/2 is 1/4. Make sure that you understand how we did that fraction, otherwise write it out and do it. Ask me in class, I can show you in class. Okay. Over here, our last one in this little section is 14 over 2. We'd bring that out to the front. 14 over 2, we're going to reduce that. And then x is x to the 1st. And since the bottom one is 3/4, we'll write that x to the 1st as x over 4/4 minus 3/4, like denominators. And then we have a y to the 1/3. And we have a z, that was at negative 6. It should come to the top and be a positive 6. So that would be z to the positive 6, because all of these are considered on top of 1. So now reduce this. This would be 14 divided by 2 is 7. X, 4/4 minus 3/4 is 1/4. Y to the 1/3 and Z to the 6th. Okay? Just follow your basic rules. This is the assignment that you should do in class. See me for the domain and range activity. You want to make sure and keep looking at those for your finals. And that is the end of that section. We'll see you in class tomorrow.